Hello everybody, I hope you are well. Last session we had a practice that now I want to solve it for you. It was about balancing the equation and use them for stoichiometric problems. All alkali metals react with water to produce hydrogen gas and the corresponding alkali metal hydroxide. A typical reaction is that between lithium and water. How many grams of lithium are needed to produce 9.89 grams of hydrogen? First, we need to balance this equation. As you can see, the number of hydrogen atoms in the right part are 3, while in the left part are 2. So, for changing them to the even, I will add the coefficient 2 here. Now we have 4 hydrogen atoms here and 2 hydrogen here. If I add a coefficient 2 here, so the hydrogens are balanced. The only thing, and even the oxygen here, left and right, it doesn't have any problem, and they are balanced. The only atom is lithium. If I add number 2 here, even lithium now is balanced. So I will use this balance equation to solve this stoichiometric problem. How many grams of lithium? We need to find the grams of lithium while we have the grams of hydrogen. And we know that 1 mole hydrogen has the molar mass of 2.016 gram of hydrogen. At this part, as you can remember, we have converted grams to mole, and then in this part we want to use the stoichiometric ratios, the balanced ratios that we can get from the equation. We can say that as you can see, 1 mole hydrogen from the balanced equation equals to 2 mole of lithium multiplied by 1 mole lithium has a mass number of 6.941 gram of lithium. They go with each other easily, and the answer is 68.1 gram of lithium that can be that are needed to produce 9.89 grams of hydrogen. In this lesson, I want to talk about limiting reagents. What does it mean? Limiting reagent is the reactant that is completely consumed in a chemical reaction. For example, in a reaction with sodium ions and chloride ions, after production of sodium chloride, the only reactant that is remained is sodium, which is called excess reagent, and the chloride was the limiting reagent, which is consumed totally. A simple example regarding this definition is that consider you want to prepare a cake and you have 2 boxes mixed plus 12 eggs. After mixing them with each other in the products, you have 2 batches of brownies while 8 eggs are still remained. So eggs are like reactants present in excess reagents, while cake mixes are limiting reactants. Boxes mix are limiting reactant. Let's solve a problem. Consider the industrial synthesis of methanol from carbon monoxide and hydrogen at high temperature. Suppose initially we have 4 moles of carbon monoxide and 6 moles of hydrogen. Determine the limiting reagent. One way to determine which of 2 reactants is the limiting reagent is to calculate the number of moles of methanol obtained based on the initial quantities of carbon monoxide and hydrogen. From the preceding definition, we see that only the limiting reagent will yield the smaller amount of the product. Start from 4 moles of carbon monoxide. We had 4 moles of carbon monoxide, and then we use the balanced equation. Please check always that if the equation that you have is balanced already or not. This equation is balanced, so I can use the mole ratios. 1 mole methanol equal with 1 mole carbon monoxide. They go, and we have 4 mole methanol starting with carbon monoxide. So if I use hydrogen, 6 mole hydrogen, and 2 mole hydrogen is equal to 1 mole methanol, and I have 3 mole methanol. Consider that better to go. Because hydrogen results in a smaller amount of methanol here, it must be the limiting reagent. Therefore, carbon monoxide is an excess reagent. In stoichiometric calculations involving limiting reagents, the first step is to decide which reactant is the limiting reagent, and then after the limiting reagent has been identified, the rest of the problem can be solved as outlined in the following example. Today, urea is produced industrially by reacting ammonia with carbon dioxide. In one process, this amount of ammonia are treated with this amount of carbon dioxide. So, problem number A. Which of the two reactants is the limiting reagent? I said the reactant that produces fewer moles of product is the limiting reagent because it limits the amount of product that can be formed. To find the limiting reagent, we carry out 2 separate calculations. First, starting with ammonia, we calculate the number of moles of urea, and then starting with carbon dioxide, we do the same. So, for the problem number A, we first start with ammonia. We need to find X mole urea, while we have how many grams? 637.2 grams of ammonia. Using the balanced equation. Listen, first we need to convert the gram to moles. 1 mole ammonia has a molar mass of 17.03 grams of ammonia. And then we know 1 mole two mole ammonia using the equation, the molar ratio in equation. And now they go. We can find the mole of urea using ammonia, 18.71 mole of urea. What about carbon dioxide? We need to find mole of urea using carbon dioxide. 1142 grams of carbon dioxide. Conversion of gram to the mole. 1 mole carbon dioxide has a molar mass of 44.01 gram of carbon dioxide. Using the equation, we know 1 mole carbon dioxide equals to 1 mole urea. And now the result is 25.95 mole of urea. Ammonia is the limiting reagent. It is clear that because it has produced less amount of urea. So ammonia is the limiting reagent, and from the next we will only work with this amount because it is produced by the reducing limiting reagent. Question number B. Calculate the mass of ammonia formed. Okay, it's so easy. We need to find X gram of urea that we have its mole number using the limiting reagent that we found in the previous question. Multiply by using the balanced, using the molar mass. We know that 1 mole urea has 60.06 gram of urea. 1124 gram of urea. Question number C. How much excess reagent in grams is left at the end of the reaction? Well, working backward, we can determine the amount of carbon dioxide that reacted to produce 80.70 moles of urea. As you can remember, in question number A, I will go back. In question number A, using ammonia as a limiting reagent, we have produced 18.71 mole of urea. So now we need to use this amount to find the amount of carbon dioxide left over, which is the difference between the initial amount and the amount reacted. So with 80.71 mole of urea, we can determine the mass of carbon dioxide. How we can do that? We write here what we want, X gram of carbon dioxide that we want to find it using 80.71 moles of urea that we have found from the question number A. Multiply by using the balanced equation, we know 1 mole urea is 1 mole equal to 1 more carbon dioxide. Multiply by, we need to convert the mole to gram. 1 mole carbon dioxide as the molar mass of 44.01 gram. The final result is 823.4 gram of carbon dioxide. So for finding what? For finding mass of carbon dioxide, remain I need to subtract the initial amount of carbon dioxide that this equation, that this question gave us, which was 1142 gram minus this amount that has been consumed to produce urea, 823.4 gram, and the remaining 300 by 90 gram of carbon dioxide. It shows that carbon dioxide as an excess reagent, this amount would be remained after the ending of the reaction, while all the ammonia would be consumed during the reaction, because ammonia is the limiting reagent. At the end of this session, which was very short, I provided you a practice. Please solve it, because next session I will solve for you. I will give you the answer, and follow me, because next session I want to talk about the yield of the reaction and how to calculate it. What does it mean and how to calculate it? Be with me. See you next time.